I'm Manisha Kumari, and here is my project Classify Handwritten Digits 0 to 9 using Python and ANN. Okay, so I treat this project title as a problem like how can we classify handwritten digits 0 to 9. So, so here is the solution, basically steps to do this project. Okay, so for this you need Python programming language and its libraries, that is NumPy, Matplotlib, TensorFlow. An algorithm to do this project is ANN, Artificial Neural Network. But the most important question is how our model going to recognize these 10 digits. For this I used MNIST dataset, which has two parts. First part contains 60,000 images to be used as training data, and the second part contains 10,000 images to be used as test data. But maybe you have this question why we are using test data, because if we use test data so that we can evaluate how well our neural network has learned to recognize the digits. Okay, and here are the implementation steps. For this project I use Google Colab, which is always a better option to use. Okay, so firstly you install all the dependencies and packages by using this syntax: pip install TensorFlow, Keras, NumPy, MNIST, Matplotlib, and then import the packages, and sometimes it is also called dependencies. Okay, from keras.model I imported sequential, which is our ANN, and from keras.layers I imported dense method, which will give us the layers of ANN, and then import to categorical, which will transform our data, and then load the data set. For this I use two variables, that is train underscore images and then train underscore labels. Labels is basically numbers, and images is image of number 7, 0 and so on. Okay, and then I normalize the images, basically normalization of pixel values from 0 to like range is 0 to 255, then I change this negative to 0.25 0.5 to but why I do this, because I want to make our neural network easier to train. Okay, and then build the model. For this I use 3 layers, 2 layers with 64 neurons. Here you can see model.add dense method I used, and 64 activation layer is ReLU, rectified linear unit, and input underscore dimensions 784. Why this is here 784? Because the dimension of our images is 28 into 28. That's why here I use 784. Okay, and the hidden layer is model dot dense, and 64 activation is ReLU, and the output layer is having 10 neurons. Okay, because we are going to recognize 10 digits, that's why I used here 10. And then I compile the model and then train the model. Okay, so for training I used epochs. Epochs is basically number of iteration over the entire data set. Here you can observe the accuracy increases as the epochs increases. Okay, here you can see in first accuracy is 89, and then accuracy is 94, basically 94%, and then 95, and then 96, and then 96.72. Okay, 96.72 is our final accuracy. And after this, I use this syntax for doing for prediction. Okay, prediction dot prediction firstly I predict the labels, and then finally I print the images of that labels. Okay, by using plt dot imshow a pixel and gray, of course, grayscale images, and finally plt dot show, we can print our images on the screen. And that's all for my project. Thank you.